Okay, guys, here we are on, I guess it's day two, Intro to Calc day two. We're going to finish up this section. When we're done with this section, at the end of the video, you should be able to complete your Intro to Calc number one worksheet. Yesterday we got off after maxes and mins and intervals of increasing and decreasing. Just remember your intervals of increasing and decreasing bank off of the x values of maximums and minimums, okay? Just like when we talk about inflection points, how you're going to find them in your calculator is you're going to hit menu, analyze graph, inflection, and our calculator will go in. We'll do that here in a second. But what the heck is a point of inflection? That's just how we shorthand them here in calculus. We call them POIs. A point of inflection is where your graph changes concavity. Okay, you're going to go from concave up, or a bowl-looking figure, to concave down, an umbrella-looking figure. And when we see this in a minute on a graph, it is just a point you need to kind of feel it. You're going to see it. Without your calculator, you're never going to hit it exactly on, but you can kind of feel and see approximately where it is. Now, understand, intervals of concavity, giving intervals of concave up or concave down, those are intervals of x values. These intervals are dependent on the inflection point, okay? So what we're going to do, or what I'm going to do, is I'm going to make a cute little sketch down here. And here's my x-axis. I'm going to call that my x-axis. If you want a y-axis, you can make a y-axis if you wish. What I'm going to do is I'm going to make a graph. I'm going to make kind of a quartic little creature. It really doesn't matter. And excuse me, as I'm reading my x-axis, I know way down here this is going to be negative infinity. Way out here to the right would be positive infinity because our x-axis never stops. Now, when we are looking for inflection points, okay, an inflection point happens when I have a change from concave up to concave down. Like I said, you got to kind of feel it. If you go left to right from the arrow, you're going to come down and you can kind of feel somewhere right in there, there is a change from concave up to concave down, okay? So we're going to kind of guesstimate that point. I'm just going to put a little asterisk on it. And then you can kind of, hopefully you can feel yet as you go up, you're going to continue to increase and then you decrease. And then you're changing from decreasing, how can I put this? You're having a change from decreasing at a decreasing rate to decreasing at an increasing rate, which is kind of talking concavity lingo, but I can kind of feel another changing concavity right about there, generally speaking. Okay, so I know to the left of this first asterisk, I'm concave up, and I know between these two asterisks, I'm concave down, and then from this asterisk out, I'm concave up again. Okay, well, those asterisks, those are inflection points or points of inflection. Well, what we do is we would come down, we would label that x sub 1 on the axis. Actually, I'm gonna go back and I'm gonna label that little bugger in red, just for fun. Now, I gotta fix my graph because I got nutty on my graph. So from there, we're just going to take this point of inflection straight down and we're going to say that's x sub 1. Understanding the point of inflection is actually x sub 1 comma y sub 1. Here's another point of inflection. So I'm going to call this x sub 2. and its actual location would be x sub 2 comma y sub 2. So if I was asking for what is the location of the point of inflection, obviously I would be listing these points up here for the actual point of inflection. But when I'm listing an interval, intervals, when is the function concave up, when is the function concave down, well, now I'm kind of looking, and I can kind of break this all the way down into the number line here, okay? And it's nice to see from negative infinity all the way up to this x sub 1, I'm concave up, then I'm concave down, and then I go back to concave up again. So if I'm listing my intervals of concavity, I would say I'm concave up, and I also am concave down on this one. And what I would do is I would see I'm concave up from negative infinity all the way up to this x sub 1 right here. And at that x sub 1, I changed to concave down between x sub 1 and x sub 2. And then I change concavity at that next point of inflection, so I'm concave up, so I need a union in there again from x sub 2 forever and ever and ever. So this is how we will list intervals of concavity. We really didn't do that in Algebra 2. I probably don't think you did that in pre-calc last year, but you did do increasing and decreasing intervals. The only difference here is now we're looking at the curve. Am I concave up or concave down? And I'm listing my intervals off of the x values of my points of inflection, okay? So as you read this graph from left to right, okay, what we want to do is we want to see there's changes in concavity, okay? And when I'm looking at the change, it's kind of telling, concavity is kind of telling us how the curve is increasing or decreasing, okay? So if you look at this from left to right, we can see I'm decreasing at a decreasing rate way to the left, and as I come across way to the right, way out here, I'm increasing at an increasing rate. So what we're going to do is we're just going to take a quick little mini dive into this. And I don't know why that doesn't work. Kruger had a minor technological difficulty there. One thing you'll learn about me, technology and myself don't get along really well. But from the concavity intervals on the previous page, what we're going to do is we are going to sketch and then classify as concave up, concave down, or no concavity. Now, all we know here in number 1 is our function is increasing. That means it is going up from left to right. So if I'm increasing at a constant rate, what does my sketch look like? Increasing at a constant rate, that would be a line now, wouldn't it? And lines have no concavity. Now, how about I'm increasing at a decreasing rate? Okay, well, if I'm increasing at a decreasing rate, my curve from left to right has to be going up, but it needs to be flattening out as I go up. So when I'm increasing at a decreasing rate, I can see I am concave down. Now, people that are confused on that, I'm increasing. I can see this curve from left to right is going up, but I'm increasing at a decreasing rate, they say. They say it's a decreasing rate because if I look at all kinds of moments in time on this curve, okay, and as I'm looking at that, and I drew a tangent line at every moment in time on that curve, notice the slope of each line on that curve as I move from left to right. The slope of that tangent line is decreasing. That's why I say this curve is increasing at a decreasing rate. So what does it look like if I'm increasing at an increasing rate? Well, left to right, my curve's going up, but my curve has got to be getting steeper. So I'm increasing at an increasing rate. You can picture those tangent lines on that. And how would this curve be classified? That would be concave up, okay? So notice concavity is telling us how our curve is increasing. Well, what happens if we're decreasing? If we're decreasing at a constant rate, that means left to right, our curve or line is going down with no concavity. Okay? How about decreasing? I'm going to be decreasing now at a decreasing rate. Left to right, curve has to be going down, but the curve has to be getting flatter as I go down, showing a decreasing tangent line. So as I come down, I'm decreasing. Now, if I plug concavity on that, I can see if it rains, this could see concave up. It could start to hold water if we put a little dam over there at the end. Okay. How about decreasing at an increasing rate? Well, left to right, my curve is going down, but yet again, when I'm picturing tangent lines on that curve, those tangent lines are getting steeper and steeper. So it's going down. And I can see that that would be concave down. So my concavity of a function tells me how, and it'll dictate to us how a function is increasing or decreasing. Okay? So this is a pretty important topic as we go through there. And I don't know why this is not working for me again. I'm going to delete that dumb little dot. Okay. And when we come around to this next page, I don't think I need to really say much about domain and range. Hopefully you remember that as it came across in Algebra 1, Geometry, Algebra 2, and Pre-Calc. Domain is simply possible x values for the graph. And the range is only possible y values for the graph. Now, when we're talking intervals, I'm sorry I should have come back here like I did on increasing and decreasing. When I'm talking about increases of concavity, again, over here, if you stick with parentheses, okay, never use brackets on there, AP board will accept either way, okay? If you stick with parentheses always on increasing and decreasing intervals and concave up or concave down intervals, no brackets, you'll be in the clear. However, when you are coming and you are specifying domain and range must use parentheses and or brackets correctly, okay? You have to use those correctly here. And if they're not used correctly here, basically they're wrong. And you know, you can intermix. Sometimes you'll have a parenthesis on one side, a bracket on the other. Remember, infinity only gets parentheses. You can never put a bracket on infinity because it never quits, okay? So, what I want to do here quick too, before I get into this example, is I'm going to back up. Through my major malfunction, thought I had to re-record everything, but I kind of figured it out. But where I wanted to go back to, like I was saying before, when I was talking about concavity, I want to go back to the graph we started with yesterday, x cubed minus 2x squared minus 5x plus 6. And like I said, you got to kind of be able to, because now we're going to talk about intervals of concavity, you have to feel where your point of inflection is. So I can see I'm concave down here, I'm concave up here, so I can feel somewhere in here there's a change in concavity, okay? I'm not going to say there always is, but typically between a maximum and minimum, typically there is a point of inflection, but not always. Somewhere right in here. Now, if I try to use my menu trace graph, that's going to show me all the spots, okay? Oh, it missed my maximum. There it gives me my maximum, gives me my y-intercept, gives me a 0, gives me my minimum, but it's squirreled right past a point of inflection. They are important points, but your calculator is not going to find them that way. So what you need to do is escape out of trace and go menu. We're going to analyze the graph and we're going to find the inflection. Now, we can feel it in here, okay? So make sure first you're to the left of it, and then as you drag, it's going to drop it. And there it is, okay? Also, what I like to do is I like to make number lines a lot of times to make my intervals of increasing, decreasing, or my intervals of concave up, concave down. I can see, here's my point of inflection. I can put a little asterisk on it. I can see I'm concave down, and here I'm concave up. So basically what I like to do is say way out to the left, draw myself a nice number line out to the right, and I like to track that point of inflection down on my number line, and I'll label that. Okay, remember we're rounding to 3 decimals, so 0.667, and then I like to come to my number line and say, hey, I'm concave down from negative infinity to 0.667, and then from 0.667 all the way to infinity, I'm concave up. So that's exactly how I would write my interval. I would say concave up. Doesn't matter the order in which you write them. I'm going to say concave up. Ooh, bad C. I'm going to say 0.667 to infinity. Concave down. Put some colons there. I was negative infinity to 0.667. 0.667. And again, stick with parentheses on intervals of concavity and intervals of increasing and decreasing, and you will always get them right, okay? Only stating domain and range, are they picky on what you're gonna, on which parenthesis or bracket you use, okay? Now from here, what we're gonna do is we're gonna do this example, okay? So grab your calculator again. If you forgot, I'm just going to get rid of that dot. I'm going to say tab. I'm going to up arrow. I'm going to delete everything I got in there because I don't want 2 graphs personally. And rather than using parentheses, I like my control divide feature to get me that wonderful fraction bar. And I'm going to say 3 minus 4x, down arrow to the bottom, x squared plus 1. Enter. And then there's my graph. Now what we're going to do is we're going to take this graph. We're just looking at this little bugger, okay? And we're going to answer all those questions. Y-intercept, x-intercept, symmetry, asymptotes, vertical and horizontal. Find maximums and minimums. After we find the maximum and minimums, we're going to give intervals of increasing and decreasing. And we're going to find our points of inflection. And then after we have our points of inflection, we're going to give intervals of concave up and concave down. And then at the very end, we're going to state the domain and range. Okay? Well, just looking at this, if you're looking at this, hopefully it's obvious there are no vertical asymptotes. Okay? My graph is not going off into space or going down into the depths at any point in time. It's covering all my x's, okay? So no vertical asymptotes. Horizontal asymptotes, it does appear that the top is flattening down to the x-axis and this side is flattening up to the x-axis. So it appears y equals 0 would be a horizontal asymptote, and we can kind of look at the power thing here Okay, my biggest power in the top is x to the first. My biggest power in the denominator is an x squared. Whenever the top is smaller than the bottom, y equals 0 was our horizontal asymptote. So we can answer a couple of those, but what I'm going to do while I'm here quick is I'm going to say menu, trace graph. And I'm just going to squirrel, oh, whoa. There's a 0, that's an x-intercept. I'm going to keep going to the right. There's a minimum, because it looked like it did a little dipsy-do, because it was going down, and then it did a dipsy-do coming back up to the x-axis, so I figured there'd be a minimum there. Doesn't look like anything else other than getting closer and closer to the x-axis over there. So now I'm going to come back here. Oh, squirrel, there's my y-intercept. I'm thinking somewhere in here there's a maximum. Didn't get it. Oh, there it did. Came back and got it. Sometimes it will, sometimes it won't. Sometimes it'll miss it and you have to go into the analyze graph. And looks like it's just dipsy diving down. So now what I'm going to do is I'm going to escape out of that. And I'm going to take that maximum there. I'm going to take that y-intercept there. I'm going to take that x-intercept there. And then that's my minimum. Okay. What we're going to do is I'm going to go back to the other page and I'm going to fill in the information I know. Okay. So try not to hit stop recording like I did last time. And like I said, y-intercept, we could see it. The y-intercept was 0, 3. The x-intercept we got right off our calculator was 0.75 for the decimal freaks, 0. Symmetry, when we looked at that, does this look like it has any symmetry across the y-axis? Nope, doesn't look the same. Definitely not x-axis symmetry because I can see these points. Now if I took negative 0.5, that's got to reflect across to where 0.5 would be, and that line would not go through the origin, so there is no symmetry here. So I'm going to say none. Whoa. It's freaking me out. None. Put that back in there. Vertical asymptotes, we said none. Horizontal asymptote, we could say y equals 0. And we can say power thing for the reason, power thing from yesterday. Or when you go in and trace, you could put a really big number like 1,000 and it's going to show a y value getting really close to 0. Okay? Maximums and minimums. I think we had maximums and minimums. The maximum was negative 0.5, 4, and the minimum was 2, negative 1. Okay? Now to see the increasing and decreasing intervals, okay? One thing you can do is draw your own number line. Okay? Here's positive infinity. Here's negative infinity. And I had a maximum here at 0.5. I had a minimum here at 2. Okay? Now what happened as you're looking at your graph? As you're looking at your graph, what happened is I was increasing to negative 0.5, then I decreased to 2, then I increased forever and ever. So I'm just going to look here and I'm going to say I increased, then I decreased, then I increased. So it's like an M. So increasing, I have an interval from negative infinity all the way up to negative 0.5. And then from 0.5, negative 0.5, until 2, I decreased. And then union, because there's 2 of them, at 2, forever and ever, I increased again. So that's how you would do your increasing and decreasing intervals. I like to make a number line, and I like to put the x of my maxes and mins on that number line with positive and negative infinity. And then I like to label between there when I'm increasing and decreasing, and then just go back and pluck them right off of that. Okay. Now the next thing we're going to do here quick is hopefully come on. Had a clicking issue again, but the last thing we're going to do here is we're going to find points of inflection and then give the intervals of concave up, concave down. Okay, and then domain and range. So what I want to do is I want to come back to my graph. And what I personally want to do is I can tell, okay, I'm going to read this. Before I do this, I want to get rid of these dots for me personally because it'll be less busy on my screen for you. All you got to do is click on them, hit delete. But as I'm looking through here, my graph is increasing at an increasing rate, and then it keeps increasing, and now because my curve is flattening, I'm increasing at a decreasing rate. That means somewhere right in here, I had a change of concavity. I have something from concave up. Well, I'm increasing at an increasing rate, and then sooner or later I increase at a decreasing rate. So somewhere this is concave up, this is concave down. There's got to be a point of inflection I'm feeling somewhere in here. I can see concave down. I can see concave up. I feel a point of inflection here. Now this one's really hard to see out here, but I do see concave up. But sooner or later, this curve is coming up, and it has to turn and flatten and get closer to the x-axis. So I'm feeling one in here as well. So how we're going to find them, we're going to say menu, analyze graph, inflection. So I'm going to come way out, and I'm going to drop it, drag it, boom, there it is. I'm going to grab that guy. Then I'm going to go back to my menu, analyze, give me another inflection point. I'm going to go tight to this one, and I'm going to drag, oh, there it is, and I'm going to hit enter and it drops it. I'm going to drag that up. I said I felt another one out here, so I'm going to go menu, analyze graph, inflection, and I'm going to go tight to that one, and there it is, boom. And if you think there might be another one, you can say menu, analyze graph, inflection, go tight to it, and there's nothing. Okay, so then you hit escape on there. So those are my points of inflection. Remember, we're rounding those to 3 decimal places. So what I'm going to do is I'm going to come back, and I can see I'm concave up, concave down, concave up, concave down. So I have 2 intervals of each, okay? And when I come back, we will see that. So I am going to go, whoop, my points of inflection. Had a few of them, okay? The points of inflection are listed as ordered pairs. So I have negative 1.099, comma, 3.349. Now, because these are points, these are not intervals, they are not unions, they are independent. So I go 0.218, comma, 2.032, comma, then I have 3.132 to negative 0.882. Okay? And now to get my intervals, what I would do, truthfully, is I like making a line, infinity, negative infinity. And on that line, I'm going to take my first one, I'm going to say negative 1.099. And the next one I'm going to say was 0.218. This line does not need to be to scale in any way, shape, or form. 3.132. Now, when I looked, I was concave up, I believe. Then I was concave down on my graph. Then I was concave up. And then I changed to concave down. So I can see concave up was negative infinity up till negative 1.099. And then at negative 1.099 all the way until 0.218, I was concave down. Now I'm going union with 0.218 until 3.132, and then union with 3.132 forever and ever and ever. Okay? Last thing we have is domain and range. And we're out. Domain and range. Check it out. This blue line, no vertical asymptotes, goes on, looks nice and continuous, never stops. Domain is all real numbers. However, from my maximum to my minimum, the range goes from minimum to maximum. It only covers those y values in the middle, right? So what we would do is we would look back at our maxes and mins, okay? First and foremost, I can say the domain, I can say it's all real numbers. Or I could say from negative infinity to infinity. I can use interval notation, okay? My range is going to go from the y value of my minimum all the way up to the y value of my maximum. So if this works for me, that dirty dog did it again, but I'm going from, my range is going to go from negative 1 all the way up to 4. And notice it gave me those values, so those have to be closed brackets. So I got a couple ways to try to do this. I just got to find a better spot for that pause button, but that's okay. I'll figure it out on the next one. But my range, okay, I'm going from negative 1 all the way up to 4, and it does include them, okay? Or I could also say my y's are greater than or equal to negative 1, less than or equal to 4. I could do that as well. Okay? Either way, I would say get familiar and get happy with interval notation. There's usually a little bit more interval notation than there is the other on the AP. However, I was going to do another example, but I don't think I need to do another example. I think you guys can just go to work on your Intro to Calc number 1. We will talk to you later on.